Okay, moving into the review questions, I had a question about number 1D. So I just copy and pasted the answers for A, B, and C here because I'm going to use the answers from A and B to talk about the answer for D. So D says, why is it possible to conclude that the vectors A, B, and C are coplanar? So we had these original vectors A, B, and C. And so when I look at the answers of crossing A and B, I got 2, 0, 2. And when I crossed B and C, I got -4, 0, -4. So what I notice is that 2, 0, 2 is related to -4, 0, -4, right? If I take this this cross product over here, and if I were to multiply it by a scalar multiple of -2, then I would get the cross product of B and C. So -2 times the cross product of A and B is equal to the cross product of B and C. And so what that means, like, if I think about this spatially, is these guys are collinear, right? If I can write them as a scalar multiple of each other, they are the same vector just with a different magnitude. And so they're stretched out in a different direction because the multiplier is negative. So I've got, so it's like I've got this one vector, let's say this is the cross product of A and B. Well then, the cross product of B and C is just twice as long in the opposite direction is what we figured out. So let's say that's twice as long in the opposite direction. But remember that I found, so this guy here, let's just label these things. This guy here is A cross B, and this guy here is B cross C, right? So that's what we figured out. They just go in opposite directions twice as long. But remember that A cross B came from taking some vector B and crossing it and finding, so if I got this B here, oops, and I've got A here, let's say that those are my A and my B. I'm just drawing them. I'm not actually referencing the points, so I don't actually know if that's the right direction or anything like that. But what happens when I cross A and B, I'm finding this resultant vector is going to be perpendicular to A and B, right? So this guy sticks out perpendicularly. But then over here, when I cross B and C, this resultant would have to be perpendicular to B and C. So let's say vector C is like some third, and you have to remember that these are shooting out into 3 space. So this is not a flat picture, this is a 3-dimensional picture. So it's almost like C would be like shooting out of the screen towards you. So if this is vector C, this resultant over here would have to be perpendicular. So this is like a 90-degree angle with each of these. And so the only way for this to happen, for BC to be parallel to AB but also perpendicular to these, is if A, B, and C lie in one flat plane, right? They all have to be on the same angle with each other, kind of in comparison to these cross product resultant vectors. So I hope that explains that that A, B, and C must be coplanar. The second question that I had was number 2, C and F. So given that I, J, and K represent the standard basis vectors, and we've got that I is 2i minus j plus 2k, and B is 6i plus 3j minus 2k, determine each of the following. So part C is asking me for the magnitude of A minus B. And so you can leave them in terms of I, J, and K, or if you prefer, you can change A to look like this in component form, and you could change B to look like this in component form. So you could use either version here because they're not telling me I have to give my answer in terms of anything for any of these guys. So if you prefer the component forms, go for that. We're going to subtract the 2 vectors. So this is just like when I add 2 vectors, I just subtract the components in the order that they're showing up here. So the A components minus the B components. Or you could write out the A vector in terms of the standard unit vectors minus the B vector in terms of the standard component vectors. So this is just another option, or you could just be subtracting the components of those point forms. And so here when I combine these like terms, I'm going to get 2i minus 6i, that's negative 4i, and then negative j minus 3j, so that's minus 4j, and then 2k minus negative 2k, so 2k plus 2k, or plus 4k. And then at this point you might want to change it to a component version, because we know how to take the magnitude of a component vector. We just take the square root and we square each of those components. Oops, I just did the, oops. And so we get triple 16, so 48. And then you would reduce that to lowest term. So what can we take out of here? We can take out a 4. We can take out a 16. This is 3 times 16. So 16 times 3, and then we can take out the 16 is 4 root 3. And then for F, part F is saying A dot with A minus 2B. So again, I can do the subtraction like this, but just putting a 2 in front for this question. I would write a 2 in here and then expand that through. Or again, you can be writing them in component form. So, oops, I've got my A vector dotting first. I'm going to leave that until later because I'm doing the subtraction because it's in brackets. I'm doing that first. Or the other thing you can do is expand the dot product in. You could do A dot A and then minus 2 A dot B. That's possible as well. Or I can just do the subtraction here because I've got them. So I'm going to do the A vector. Remember when I changed that to component form, I got this. Minus 2 times the B vector. Remember when I changed that to component form above, I got this. Right? I'm just using these component versions of A and B. And so then I've got A dot, and subtracting these guys, I've got 2 negative, so that guy didn't change. And then I'm going to just multiply this negative 2 through here. Or you could leave the negative out and subtract the components, it doesn't matter. And so now I'm just adding up my components. And then I'll just rewrite in my A vector and do the dot product of those two. So remember, for the dot product, I'm multiplying the matching coordinates or components and then adding up. And so I get 19 over here and negative 20, so negative 1 altogether. All right, so that's it for those two questions, and I'll go on to make a new video for the next set of questions.